Algebra of functions are the ways we can combine two functions together via the four main arithmetic operations. The domain is the intersection of the two functions. So if f and g are functions with domains a and b, then the algebra of functions, the four here, are defined as follows. The sum of the two functions is just the intersection of the domain of the two functions. The difference of the two functions is the intersection of the two domains. The product of the two functions is the intersection of the two domains. So the first three are the same. Now the division of the two, the quotient of the two functions, is a little bit different. It is still the intersection of the two domains. However, you cannot have division by 0. So whatever values will give you 0 for the g function for the denominator must be excluded. So it's still the intersection of the two, but you might have to remove an extra value or so from that domain. So let's look at a couple of these domain questions. We're going to find the domain for all four of the algebra functions. So the first one we're going to do is we're going to do the sum. So f plus g of x, we know it's just adding the two functions together, so square root of x minus 2 plus x squared minus 16. And so these are the two functions added together. Now when it comes to the domain, you have to find out either what will cause division by 0 or what will cause a negative number under an even radical. In this case, we have no fractions to deal with, but we do have a square root, the x minus 2 over here. So what we're going to do is we're going to take our x minus 2 and we are going to set it strictly greater than or equal to 0 and solve. When we do that, we're going to get x is greater than or equal to 2. So this is the domain of this part of the function, but we also have our g function, which has no restrictions whatsoever. So no restrictions for the first, and we have some restrictions for the second, which means we need the intersection of the two. So the domain here is going to be bracket 2 to infinity in interval notation. So this would be the domain of the sum function, sum of the two functions here. Now we're going to do the difference. So f minus g of x, again, is just the same two functions, except we're going to subtract them. So it's going to be minus x squared plus 16. Again, no fraction to cause division by 0, but we do have a square root, so we're again going to take what's underneath it and set it greater than or equal to 0. Then just solve for x. X is greater than or equal to 2, which is the exact same thing we had before, which means because there's all real numbers for the g function and a restriction for the square root function for f, x having to be greater than or equal to 2, we want the intersection of those two. So the domain again is bracket 2 to infinity as the domain of the difference. Next, we're going to do the product. So f times g of x, and that's just going to be square root of x minus 2 times x squared minus 16. Don't really need to distribute this because we just want the domain. So just like with the first two, the only restrictions we have to deal with are the square root because there's no fraction. So actually I don't need the equal sign here. Just going to take x minus 2 and set it greater than or equal to 0. And then solve for x, which is again, x is greater than or equal to 2. Again, the only restrictions we have are x has to be greater than or equal to 2. So our domain has to be bracket 2 to infinity. And this is the domain for the product. Last, we have f divided by g, the quotient. of the two functions. So it's going to be square root of x minus 2 up top and x squared minus 16 at the bottom. Now this time we do have a fraction and a square root. We have two things we have to deal with. So first, I'm going to start off with the square root because we've already done that a few times. So it's very easy. X minus 2 greater than or equal to 0, which is going to give me x is greater than or equal to 2. So the domain of this part is 2 to infinity. But we also have a fraction. We got to make sure we don't get 0 in the bottom. So we're going to take what's in the bottom, x squared minus 16, and set it equal to 0. And we got to make sure we don't want what it equals to. So we're going to add 16 over. And then we're going to square root both sides. And when you square root both sides, you must remember to have plus or minus. So here, the domain of the g function is everything but -4 and +4 because it's in the denominator of this quotient. Now, we need the intersection. -4 is not within this, so it doesn't matter. We don't need it, and it's not in here, so we don't have to worry about it. However, 4 is also a number. We can't have it, and 4 is within this interval because it's 2 to infinity. So we must remove 4 from the domain. So we can say that the domain is 2 to 4, parentheses, union 4 to infinity. And this would be the domain of the quotient of the quotient of these two functions here. So you gotta be careful. The first three, not too bad. They typically repeat a bunch of times. But the division of the two, you have to be careful, will cause division by 0.